So the second way we're going to learn how to find slope is just from 2 points or 2 coordinates. So sometimes a graph really isn't the best way to find a slope. It just depends on the situation. So like in these graphs, I don't really have my coordinate line, so it might be a little difficult to count my rise and run. Or what if I have a graph that like goes up like 123 and then over negative 46? Do you really want to count to 146? Probably not. So there's a better way to do those particular problems. So if we kind of look at, I still want to use the graph this time to kind of explain how we do it without a graph. So normally we would find our rise over our run, right? This was our formula we talked about in our last video. And when we're rising, what we're really looking at is how our y coordinate is changing, right? This is our y-axis here. So vertically, we're looking at our y coordinate and our y coordinate and saying, how far apart are those? How far apart is 3 and negative 1? Well, they're 4 apart, which on this graph I could count. But again, if I had a graph that they were 100 apart, we don't want to count 100 different blocks, okay? So I'm just using small numbers for an example. So our y coordinates, our rise, are 4 units apart. So you can either just think about that or we can subtract them. So 3 subtract the negative 1. So subtracting a negative, keep, change. That's how we get to the 4. And then our run, we're looking at how our x is changing, right? We're moving along our x-axis there. So our x coordinates are 4 and negative 2. So again, I can just think how far apart they are because we're using small numbers, but sometimes we are going to want to make sure we are subtracting them. 4, subtract that negative 2, keep, change. They're 6 units apart, and then reduce. We can get our slope to be our answer of 2/3. Okay, so there's a formula we can use that here that sets up that subtraction because we can't always think through those very easily. So slope is going to be your y coordinate subtracted on the top, right? This is our rise, which is why sometimes in class I spell rise wrong to remind you that y goes on top, over run. Okay, so we're always subtracting and then make sure if there was a negative, we have subtraction and a negative number. So these 1s and 2s are really just saying, okay, our first point and our second point. That's the only reason what the 1s and 2s are for. So basically, if I start with this y, it makes sure that I'm starting with that same x on the bottom. So this coordinate's kind of aligned vertically. And if I accidentally switch one of these around, it's just going to give me the wrong sign slope. So that's really what we're doing here. So we'll look at using the formula here on the next page. I'll do an example or 2 together, and then I'll let you try a bunch. So if we have the coordinates 6, 2, and then negative 3, 5. So this is an x coordinate, this is a y coordinate. Same thing over here. We have an x and we have a y. So what we're going to do is we're going to label, this is my first point, so we're going to put 1s on those. This is my second point, so we're going to put 2s on those. So my formula is taking the second point and you subtract the first point for our rise. So I'm going to take that 5, my second y, and I'm going to subtract my first y. And then the bottom for my run, I'm going to take my second x and subtract my first x. So I have negative 3, subtract 2. That's kind of how we set the problem up. And then we just do the math. Straight across, 5 minus 2 is 3. Negative 3 subtract 2. If you need to keep, change there, you can. Gives us negative 5. Oops, I wrote the y there. This is a 6. That's why this doesn't match up with my answer. So negative 3 subtract 6 gives us negative 9 there. Whoops. And then reduce down to a negative 1/3. So if you saw my mistake, I accidentally put a y on the bottom there, and we should have an x. All right, since I messed that one up a little bit, we'll do one more together, and then I'll let you try the other ones. So this is going to be negative 7, 1, 0.08. So you don't have to write down this formula, and you don't have to label these if you don't want to. The more you do this, the less you'll want to label them. So you just really need to remember this is your y, it's my second y, subtract my first y. Second x, subtract my first x, which is negative, so I have to subtract the negative there. So 8 minus 1 is 7. Keep change is 7. 7 over 7 is 1. So we have a slope of 1 there. So again, we're still finding slope. These numbers are still describing steepness of a graph. We aren't just visually, we aren't looking at a line. We're just doing it with the coordinates. So here are 2 for you to try. Let's go ahead and try the video, or pause the video and try those problems. So, and then here is what you should get. We have our y subtracted on top, our x's subtracted on the bottom. Okay, so I want you to pause and try the next two. All right, now let's take a look. Okay, so the first one was pretty normal for what we normally were doing those last problems. This second one, though, might have been a little tricky. So if you stopped here, that's probably fine for our first example, but on the quiz or test, I want you to go one step further. I need to know that you understand this is a 0 slope. Okay, 0 divided by 5 is 0. Okay, so you need to tell me that that's the type of slope we have here. Is a 0 slope. I need to know that. So then last 2 to try, pause and try those 2. All right, and check in to see how you did. Okay, so again on the second one here, 0 on the bottom. So this means 2 divided by 0. You cannot divide by 0. If you type that into a calculator, it will say error. This means you have an undefined slope. So again, I don't want you to stop here on a quiz or test. You need to tell me you know that this is an undefined slope. So some of you will get confused between the two. So 0 on the top is a 0 slope because you can take 0 and divide by 5 or any other number. On this one, we can't take some number and divide by 0. So 0 on the bottom means undefined slope.